Welcome to this explainer. Today, we're literally decoding the deepest biological mechanisms of human sleep. We are going to connect the dots between your circadian biology, your autonomic nervous system, and these complex hormonal feedback loops. By the end of this, you're going to understand exactly how your body actually shifts from a state of alert wakefulness down into deep restorative recovery. Let's get into it. So let's kick things off with a question that, honestly, so many of us have agonized over. Why on earth can you be physically exhausted, like bone tired, yet completely unable to sleep? You lie there, your body feels like lead, but your brain is just racing a million miles a minute. It's that dreaded wired and tired paradox. Now, for the longest time, people just wrote this off as a failure of willpower, or maybe just having a naturally anxious personality. But the latest science, it tells a completely different story. This is absolutely not a psychological weakness. It's a fascinating physiological mystery, and we're going to solve it today. I actually saw this quote from a user on an insomnia forum, and it just hit the nail on the head. They wrote, "What you're describing is classic chronic hyperarousal. Your sympathetic nervous system is stuck in overdrive, keeping your body on high alert. This isn't just anxiety, it's a neurophysiological condition." And you know what? They're completely right. If you can't sleep, your body is actually doing exactly what it evolved to do. It's detecting a threat. The problem is just that your threat detection circuitry is fundamentally misfiring.
All right, section 1, the wired and tired brain.
Clinically speaking, we call this state hyperarousal. Basically, it's a state of persistent nervous system activation. So your homeostatic sleep drive is practically shouting at you to go to sleep, but your sympathetic nervous system, that's your fight or flight response, is entirely dominating the system. It's just pumping out cortisol and noradrenaline. And you can feel this autonomic overdrive physically, right? You might notice you're clenching your jaw, you're taking shallow breaths up in your chest instead of your belly, and you've got an elevated resting heart rate even though you're lying perfectly still in bed. Moving right into section 2, unlocking the emotional brain. Structurally, a well-rested brain is just a totally different landscape compared to a sleep-deprived one. When you're well-rested, your medial prefrontal cortex, which is the logical, rational part of your brain, exerts this top-down inhibitory control over the amygdala, your emotional alarm system. Think of it like a brake pedal. But when you're sleep-deprived, that functional connectivity gets incredibly weak. The prefrontal cortex essentially goes offline, and the amygdala instead links up with the locus coeruleus, which is the brain's main source of noradrenaline. Suddenly, your emotional center is hot-wired straight into your adrenaline center. And the data on this is absolutely wild. Just one single night of total sleep deprivation, or even 5 nights of partial restriction, like, say, only getting 4 hours of sleep, triggers a massive 60% amplification in amygdala reactivity to negative stimuli. 60%! Your brain becomes incredibly emotionally volatile. It's constantly scanning the environment for threats and drastically overreacting to minor stressors. So how do we fix this? Well, sleep, specifically REM sleep, basically acts as free overnight therapy. During the REM stage, your brain completely shuts off the release of noradrenaline. This is huge because it allows you to process all the emotional memories of the day without that chemical stress response attached to them. But here's the catch. If your sleep is fragmented, you miss out on this REM therapy. Those emotional memories stay raw, your amygdala stays hyperactive, and your HPA axis, your hypothalamic pituitary adrenal axis, gets locked in a state of nocturnal alarm. Okay, section 3. Let's talk about sensory sensitivity and sleep. This brings us to a really fascinating genetic trait called sensory processing sensitivity, or SPS. Now, to be clear, this is not a disorder. It is an innate, evolutionarily conserved trait found in about 15 to 20% of humans, not to mention over 100 other animal species. If you have a highly sensitive nervous system, you experience much deeper cognitive and neurological processing of everything, environmental, social, and internal stimuli. You literally feel the world more intensely. Now, to actually fall asleep, your brain has to pull off something called sensory decoupling. This is when your thalamus actively suppresses incoming inputs from the environment, so your cortex can finally transition down into deep, slow-wave sleep. But for highly sensitive brains, this gating mechanism often fails. EEG studies actually show they have altered cortical centrality. That means the sensory processing regions of their brains stay continuously active, just quietly monitoring the room. So a subtle noise or a slight shift in temperature doesn't just wake them up, it completely shatters their deep sleep architecture. And we know this isn't just a learned habit because it's observable right from childhood. Kids with sensory sensitivities show massive, statistically significant correlations with sleep onset delay, bedtime resistance, and pre-bedtime anxiety. It is not a behavioral flaw. Their lower neurological thresholds literally, physically prevent them from rapidly shifting from alert wakefulness into that first stage of sleep. Which brings us to Section 4, the autonomic nervous system. So, how does all this sensory overload translate into physical exhaustion? We're basically looking at this biological funnel effect. Because you have this heavy sensory load during the day, your sympathetic nervous system just stays activated. This chronically triggers your HPA axis to keep pumping out cortisol. Over time, your cells actually become resistant to this cortisol, which causes the HPA axis to lose its negative feedback capacity. It basically loses its built-in off switch. And the result? A flattened or even inverted diurnal cortisol curve. Instead of your cortisol dropping nicely at night to let melatonin rise, your body is flooded with evening cortisol, locking you right back into high alert. Because of this constant overdrive, highly sensitive folks actually show significantly lower vaguely mediated heart rate variability, or HRV, even when they're just resting. Now, HRV is the gold standard metric for how flexible your nervous system is. Having a lower HRV reveals a dangerous over-reliance on that sympathetic drive we were talking about. It basically means that the physiological cost of simply existing and trying to self-regulate is so much higher for a sensitive nervous system. All right, Section 5, the safety signal framework. Here is the good news. We can manually override this hyperarousal. Neurological research shows we can actually use what are called safety signals. These are specific sensory cues that completely bypass cognitive worry. Because let's face it, you cannot just think your way out of hyperarousal. Instead, these sensory signals act directly on the posterior insular cortex and soothe this deep brain region called the bed nucleus of the stria terminalis. By physically sending these signals of safety, you forcefully shut off your body's threat response. One of the absolute best safety signals is the 4-7-8 diaphragmatic breathing method. It's simple. Inhale through the nose for 4 seconds, hold for 7, and exhale slowly for 8. But why does this actually work biologically? Well, by slowing your breathing to exactly 6 breaths per minute, you stimulate pulmonary stretch receptors in your lungs. It also leverages something called the Bohr effect, where increasing your carbon dioxide slightly actually enhances oxygen delivery to your tissues. This combo sends a massive signal of safety directly to your brainstem via the vagus nerve. But it's not just breathing. There are other incredible mechanical interventions for what we call somatosensory autonomic downregulation. Vocal vibrations, like humming or chanting, literally vibrate and stimulate the laryngeal branches of the vagus nerve right in your neck. Thermal regulation, like splashing cold water on your face, triggers the trigeminal vagal reflex, forcing a parasympathetic rebound that instantly drops your heart rate. These are actionable biological hacks that force your nervous system offline right before bedtime.
Finally, Section 6. Let's look at optimizing your sleep environment.
Now notice a massive shift happening right now in clinical treatments. Traditional cognitive behavioral therapy for insomnia relies on strict sleep restriction, like forcing you to get out of bed after 15 minutes if you aren't asleep. But if you have a highly sensitive nervous system, that abrupt restriction just triggers huge cortisol and adrenaline spikes. It backfires. Instead, adapted CBTI uses sleep compression and a 9-hour eyes closed rule. Just allowing yourself to lie there quietly, relaxed, with your eyes closed, blocks visual input, preserves your neural energy, and completely removes the performance anxiety of forcing yourself to sleep.
Alongside this new mindset, you've got to build a strict sensory diet for your bedroom. And guys, this isn't a luxury, it's a biological necessity to achieve that sensory decoupling we talked about earlier. This means aiming for tactile neutrality with seamless nightwear and really breathable sheets so you don't overheat. It means auditory gating, maybe using continuous brown noise. It means using proprioceptive deep pressure, like a weighted blanket calibrated to about 7 to 10% of your body weight, which clinically lowers cortisol and boosts serotonin. And of course, total visual blackout to protect your natural melatonin production.
To really pull the whole shebang together, let's look at clinical expert Julie Bueland's 5-step routine. It starts with cognitive offloading, basically journaling to just get that nighttime rumination out of your head. Next is physical deceleration, just intentionally moving slower. Step 3 is super fascinating, hydrothermal therapy. Taking a warm bath raises your core body temperature, and then when you step out into a cool bedroom, that rapid temperature drop brilliantly signals your brain's hypothalamus that it is time for deep sleep. You follow that up with somatic preparation, like magnesium, and acoustic isolation to just safely lock the environment out.
So I want to leave you with a question to think about. Now that you know exactly how the HPA axis, your amygdala, and these sensory gating mechanisms actually work, will you keep fighting your biology, or will you redesign your environment to finally signal absolute safety to your nervous system? Because once you understand the deep science of your own sleep architecture, you literally have the power to stop fighting that wired and tired paradox and start optimizing it for true restorative healing. Thanks for joining me on this explainer. I hope this helps you get the rest you deserve.